Hello viewers, I am Kausalya. Today we are going to solve example 14 in chapter 13. The problem is an open metal bucket is in the shape of a frustum of a cone mounted on a hollow cylindrical base made of the same metallic sheet. The diameters of the two circular ends of the bucket are 45 cm and 25 cm. The total vertical height of the bucket is 40 cm and that of the cylindrical base is 6 cm. Find the area of the metallic sheet used to make the bucket where we do not take into account the handle of the bucket. Also find the volume of the bucket. Also find the volume of water the bucket can hold. So here the problem deals with a bucket, and here you see it is clearly mentioned that we have a open metal bucket like a frustum of a cone. Here we have a frustum and there is a hollow cylindrical base. The base is just like a cylinder and we have a frustum. And again the diameters of the two circular ends, they are given as 45 and 25. So in frustum we are having two circular areas, right? One at the top, another at the bottom. So one diameter is 45 and another one is 25. And the total vertical height of the bucket is given, it is 40 cm, and that of the cylindrical base, the base is 6 cm. That is, the vertical height of the cylindrical base is 6 cm. So now we have to find the area of the metallic sheet used to make the bucket. So again you have to consider a steel bucket or normal bucket, aluminum bucket, something like that. And here we are neglecting the handle. Then the next thing is we have to find the volume of water that the bucket can hold. So you see here, this is our diagram. We have a bucket. So this bucket has two circular areas. The circular area, that is the diameter of one circular area is 45 and that of the other here is 25. And the vertical height, right? The total height of the bucket here is 40 and the vertical height of the cylinder. So here you see till this, there ends the frustum of the cone, and here you see it is like a cylinder. So here the height of the cylinder is, it is 6 cm. So first we are writing the given data. The height of the bucket is 40. Then how to find the height of the frustum, because frustum is only this area, right? So how to find the height of the frustum? This is the height of the bucket and this is the height of the cylindrical part. So then you have to subtract 6 from 40 to get the height of the frustum. So 40 minus 6 gives you 34 cm. The next thing is we are provided with two diameters. So just calculate the radius. So here the bigger one, the diameter of the bigger area, it is 45 cm. So radius is 45 by 2. And the smaller base here is 25 diameter. Therefore R2 is 25 by 2. And height is 34. Just now we have calculated. Now the next step is we are going to calculate the slant height of the frustum. So how to calculate the slant height? Again it is based upon the formula. So here L is equal to square root of h square plus R1 minus R2 the whole square. So now we know the value of h, we know the value of R1 and R2. So just substitute the values here, and when you solve here, 45 by 2 minus 25 by 2, that is 45 minus 25 gives you 20 and 20 by 2 is 10. So here it is 10 square. So here it is 1156 plus 100, which is 1256. Now we are going to find the square root for this number. I believe you people had already studied this, but let me explain how to take a square root for 1256. So as usual, you are splitting the number as two parts. That is not two parts depending upon the number. So we are dividing, that is we are splitting it as this two number as 1. So this is 1 and this is 1. Now here we are having 12, right? So again the thing is 1 is 1, 2 2s are 4, 3 3s are 9, and what about 4 4s are, it is 16. So 4 4s are 16, it is a bigger number. Here we have only 12, so we go with 3 3s are 9. So here 3 and here 3 and here we are writing 9. So 12 minus 9 gives you 3, and as a next step you have to bring these two digits at a time downwards. So here comes 3 5 6. Now here we have only 3. Now multiply this 3 with 2. So 3 2s are 6. So write the number 6 here. And next is you need 356, and I have a 6 here. So here you can add any number, that is it may be 62 into 2 or 64 into 4 or whatever may be. So here it is 65 into 5. So 65 into 5 gives you 325. So again when you subtract, you are getting the answer as 31. Now you have no digits to bring down. So here we are simply adding zeros. So here I am keeping a dot here. Now I am bringing this 20 downwards, so it makes a number 3100. Now again you go upward, here we have 35. So 35 into 2 is 70. So write down the number 70 here. Again the same criteria, we have 70, and here you have to add, that is you have to add number here. If it is 1, here also 1. If it is 4, here also 4. Okay, just like this. So now our division tallies with 4. So 704 into 4 gives you 2816. Again when you subtract, this gives the answer as 284. Now again we have nothing to bring downwards, so just I am adding 2 zeros here. So again when you move upwards, you see 35.4, okay? You can just neglect this dot. So 354 into 2 gives you 708. And again to this 708 we are adding 4, okay? 7084 multiplied by 4, this gives the answer 28336. And here the remainder is 64. Since here we are having sufficient numbers, that is after decimal point we have calculated up to 2 digits, it is enough. So this is the method to find a square root, and now the value of L here is 35.44 centimeter. Right. Then we are going to solve the first part of our problem. It is area of the metallic sheet used. So here again when you look back at the diagram, so we have to find the area of the metallic sheet used. So here obviously just imagine a bucket. So where we will be using our sheets? So here you see this entire curved surface area of the frustum will be covered by the sheet. Then the base part, okay, here the base area will be covered by the sheet. Then when you look at the bottom part, here this is a small cylinder, and again the curved surface area of the cylinder will be covered by the sheet. Am I making things clear? If you have any doubt, it is better to view a bucket. Okay, either it may be a silver bucket, but the bucket should be of this shape. Then only you will get a clear idea. Okay, you can see the frustum of a cone as well as a small cylinder at the end. So here you see this total surface, okay, it will be made up of sheet. Then the base area will be, it will be covered, right? The base will be covered with the sheet, and finally this end part, that is the cylinder, the curved surface area of the cylinder will be also covered by the sheet. Okay, it's better to view a bucket in person, right? Now, so here we had written the terms: curved surface area of the frustum plus the base area and curved surface area of the cylinder. So just write down the formulas here. So it is pi r1 plus r2 into L, and pi, regarding we are discussing about the circular base, that is base of the bucket. So base of the bucket, you see, so this is your base of the bucket. So this base of the bucket, it resembles the area of a circle. Therefore here the formula is pi r2 square, because this is our r1 and this is our r2. So here it is pi r2 square plus the curved surface area of the cylinder. Again you see this is your cylindrical part, and this is the diameter of the base of the frustum as well as the diameter of the cylinder. Right. So here it is 2 pi R2H. Now pi is common in all the terms. So when you take pi outside, these are all the remaining terms. Now we are going to substitute the values. So R1 is 45 by 2, R2 is 25 by 2, and L is 35.44, and here it is R2 square, and here it is 2 into R into H. So as a next step, you see 45 plus 25 divided by 2 gives you 35. That is 45 plus 25 gives you 70, and 70 by 2 gives you 35. And here 25 by 2 is 12.5, and here this 2 and 2 they cancel, and finally 25 into 6 gives you 150. So again when you multiply, here we are getting this answers, okay, these values. Now again we are multiplying and we are dividing it by 7 here. So finally the answer is 4860.9 centimeter square. So this is the area of the metallic sheet used to make a bucket. Now we proceed with our second part, volume of the water in the bucket. So here what is the formula? It is 1 by 3 pi h into R1 square plus R2 square plus R1 R2. So the value of pi is 22 by 7. Here we are discussing only about the bucket. So what is bucket? It is nothing but a frustum of a cone. So here what is the height? The height of the bucket, that is height of the frustum, is 34. Here why we are not including the entire height? Because you see here we need to find the volume of water that can be filled inside the bucket. So what is the area that can be filled with the water? So this is the area that can be filled with water. So it is enough to consider only the height of the frustum, not the height of the entire part, because the base cylindrical part is provided to give a support to the bucket. Right. Therefore, here the height of the bucket H is taken as 34. And again R1, R2 all are same. Just substitute, multiply and simplify, and here finally the value is 33615.476 centimeter cube, because we are discussing about volume. So since again here we are discussing about water, I am converting this centimeter cube to liters. So I am dividing this value by 1000. So here comes the answer as 33.62 liters approximately, because here we are having 33615. So I am approximating it to 33.62 liters. So here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.